friends, so after completing a numerical on division by t theorem, I'm gonna take one more numerical for you so that you can have good hands on how to apply the division by t property for the different types of numerical. So let's start with the second numerical. So here we have to find out the Laplace of cos AT minus cos BT whole upon t. Now guys, if you observe the question carefully and if you try to compare it with some property, then you can immediately tell me that this is division by t property, because here we are dividing the function in the numerator by t. So here the division by t property for all of you. So in division by t property, we find Laplace of f of t upon t. So the function in the numerator is called as f of t, and its value is given by integration s to infinity phi of s ds. Now guys, I have covered the theorem so guys, I have already covered the theorem in the previous videos where I have shown you how to prove this division by t property. So according to this, the answer will be integration s to infinity phi of s ds, and for that we have to find out the value of phi of s, because then only we'll be able to integrate. And to get phi of s, we have to find out Laplace of f of t. And guys, in the question, f of t is the numerator. So what I'll do is, now I'll find out Laplace of numerator and I'll get phi of s, I'll put it here and I'll get the final answer. So here first of all, let's understand that the numerator is f of t. So here I'll mention that. So I'll say here f of t is this. Now students, after this we are going to find out phi of s, and for that I'll take Laplace on both sides, because Laplace of f of t is phi of s. So here we'll get now what is Laplace of cos AT? So we have seen the formula in the previous video. So if you don't know, then you should go back to the previous video and revise the formula very well. So answer of this is s upon s square plus a square minus the Laplace of this is s upon s square plus b square. And guys, I'll call this as phi of s. So as per the property, we call Laplace of f of t as phi of s, and we take this phi of s in division by t theorem to integrate and to get the answer of Laplace of this whole function. So now I'll say, using division by t theorem, we will get Laplace of this cos of AT minus cos of BT upon t equal to integration from s to infinity and phi of s, that is s upon s square plus a square minus s upon s square plus b square into ds. So now guys, we just have to integrate these terms and substitute the upper and lower limit and get the answer. So now what is the integration of s upon s square plus a square? So I know that you have done integration in low standards and you are good with integration. Am I right? So no, most of you don't know the integration. So my advice is, go back, revise integration very well, because if you want to make good score in Laplace or let's say Fourier or any higher mathematics, then you have to be very well with your basic formula. So to get the integration of this, I'll be using a property, that is f dash of x upon f of x. So this property we have done in integration. So in that we say that if the derivative of the denominator is present in the numerator, right? So here we have s square plus a square. What is derivative of this? So derivative of s square is 2s and derivative of a square is 0 because it is constant. So if I bring 2s in the numerator, then that will be called as derivative of this s square plus a square, and then we can apply the property. Now to bring 2 here, what I'll do is I'll multiply and divide this integration by 2, so that here I'll get 2 and similarly here also I'll get 2. So let's multiply and divide by 2. So here we will get 1 by 2 integration s to infinity. Now here I have divided, now let's multiply. So 2s upon s square plus a square minus 2s upon s square plus b square. So now here I'll apply the property. So property is like this: integration of f dash of x upon f of x dx is given by log mod f of x plus c. So here the numerator is a derivative of denominator, and that thing we have brought here. So 2s, you can observe here 2s is a derivative of s square plus a square. So this denominator will behave as f of x, and we will get answer as 1 by 2 log mod s square plus a square minus log mod s square plus b square, and limit is from s to infinity. Now guys, here we have log a minus log b kind of a structure, therefore here I can apply the property which is log a upon b. So here we will get half into log of a, that is s square plus a square upon s square plus b square from s to infinity. Now let's substitute upper and lower limit. Now guys, observe carefully, upper limit is infinity. If I put infinity over here, then I'll get indeterminate form, that is infinity upon infinity. And guys, since we want the finite answer of this Laplace transform, we have to adjust that infinity. So in the previous video I have shown that if you bring that infinity in the denominator, then we get answer as 0. So any finite number upon infinity is 0. So what I'll do is I'll try to bring this s square in the denominator, so that when you put s as infinity, that infinity will come in the denominator and you will get answer as 0, and 0 is a finite number. So for that what I'll do is I'll divide numerator and denominator by s square. So here we will get half into log mod. Now if I divide numerator by s square, we will get s square upon s square is 1, plus here we will get a square upon s square. Similarly, if I divide denominator by s square, we will get 1 plus b square upon s square, and limit is from s to infinity. So guys, now let's put s as infinity. So here we will get a square upon infinity, and that is 0. So 1 plus 0 will be 1. So here we will get half in bracket log of 1, because here 1 plus 0 1, 1 plus 0 1, and 1 upon 1 is 1. Middle sign minus. Now let's put lower limit. Now lower limit is exactly same, that is s. So if I put s equal to s, it is not going to make any difference, so I'll get this term again. And if I simplify this term, I'll get this term again. So I'll write down this log term here directly. So log of or log mod s square plus a square upon s square plus b square. Now guys, we all know that log of 1 is 0, so this will become 0 minus this. So negative log mod s square plus a square upon s square plus b square, and we have half also, so I'll keep half here itself. Now guys, this is what the value of the given Laplace transform. If you want to make it positive, then in the previous video I have used the property of logarithm, that is negative log of a upon b is positive log of b by a. So I can remove this negative sign and I'll make this as log of s square upon s square plus b square upon s square plus a square. So you can keep this answer, or you can convert it into positive log term. And here we got the value. So I'm sure that you understood how I got the answer, and if you want to learn more videos on engineering mathematics, then do visit to ikeda.com. Thank you very much.